Section 5.1, using fundamental identities. This is the objective. You can pause to read. I am moving on to the next slide. This is the vocabulary key concepts, co-function identities, fundamental trig identities. You have seen those, and this is the part of this that is going to be kind of challenging. Okay, moving on to the next slide. These are the co-function identities. You have to understand what they mean. Let me just clarify this one, and it's actually not too complicated. You have seen something like this on the previous chapter. You saw a problem like this on the quiz. Let's look at this right triangle. Notice that the sides of the triangle are A, B, C. This is reference angle U. This is reference angle pi over 2 minus U. Let's compute cosine of U. Cosine of U is equal to, it's going to be adjacent over hypotenuse, which is equal to A over C. Now let's look at this reference angle pi over 2 minus U, which is right here. And let's compute sine of this reference angle, which is opposite over hypotenuse, and that's how I get A over C. Notice that these two are equal. That's basically what the co-function identities are trying to show you. And here's the rest. You can pause to copy them, but if you look at the right triangle that you see there, you should be able to see why they are true. Moving on to the next slide. It says use the given values to evaluate, if possible, all 6 trig functions. So they give you tangent of x equal to that, cosine of x is equal to that. By looking at this, we have done this before, you should be able to tell me that x, this means that this little notation symbol means x is an element of quadrant 3, or x is in quadrant 3. So I need to evaluate all 6 trig functions. So first, let me evaluate sine. And basically what I'm doing, I'm using the Pythagorean identity. Sine squared plus cosine squared equals 1, and I'm solving for sine of x. So I have to take the square root of 1 minus cosine squared. I know what cosine is, which is right here, then I square it. And notice that I have negative. Why do I have negative for sine? Because I'm in quadrant 3. And I go through the math, simplify this. That's how I end up with negative a half. You don't have to do this problem this way. You can still use the process that we learned in the previous chapter. I'm just trying to use the trig identities you have seen up to this point. Then cosecant of x, that one is easy once you know sine. I know this is sine, so it's going to be reciprocal. Then secant, I know it's the reciprocal of cosine. I have cosine, I go through the math, I simplify, and this is what I get. Cotangent, reciprocal of tangent. I know tangent, that's how I get radical 3. Number 2 says use the same directions. They give you different values for the trig functions. This symbol that you see there right next to the cotangent is phi. Cotangent of phi equals negative 5. Sine of phi equals radical 26 over 26. Again, you should be able to see why the phi is an element of quadrant 2. We have done that before. Tangent, that one's easy, just reciprocal of this. Cosecant, reciprocal of sine. Moving on, cosine, I'm using this fact. Cosine is the same thing as cotangent of phi times sine of phi. I know cotangent, I know sine, so I multiply those two, and that's how I get cosine of phi. And then to compute secant of phi, all I'm going to do is I'm going to use cosine of phi and use the reciprocal 1 over this, and go through the math, and this is what I get. Number 3, same directions, but in this case, notice that they're giving you this cosine of pi over 2 minus theta equals 3/5, and cosine of theta equals 4/5. By using the cofunction identities, I know that this is equal to sine of theta. So now I know that sine of theta is equal to 3/5. So before I continue, I know that theta is in quadrant 1, cosine is positive, sine is positive. And this is going to help me find the sine of the other trig functions. Cosecant is just reciprocal sine. Secant, reciprocal cosine. Tangent is sine over cosine. I know those two values. And I get 3/4. I have to do a little bit of algebra here, more like pre-algebra. And cotangent is just reciprocal this, 4/3. Everything positive because theta is in quadrant 1. Moving on to number 4. This is where it gets a little bit challenging. What you want to do is verify the identity algebraically. You have done some of these. They're going to start getting a little bit harder. So I'm going to have to make one side equal to the other side. You always want to work on the one that is most complicated. So of course I'm going to work on the left side. So I got to do something with the left side. So I took secant, reciprocal, identity, tangent is equal to sine over cosine, reciprocal, and I rewrote this as sine theta over sine theta, the 1. Still the same thing. Now, why did I do that? Because I have to do something. I have to make it look like the left-hand side. And if I do this to this one, rewrite it as sine theta over sine theta, notice what you're going to see. Here, on the left-hand side, I can pull out a 1 over cosine out of this binomial, and I'm left with this. In the same manner, I can pull out a 1 over sine out of this binomial, and I'm left with 1 plus sine theta. At this point, I am going to FOIL these two binomials. This is what I get. Using the Pythagorean identities, I know that this is equal to cosine squared theta. And at this point, I have cosine squared theta over 1. So I can cross one of them out. And I'm left with, so I cross this one out with cosine theta here. And then I'm left with cosine theta sine theta, which is cotangent theta, which is this is what I want it to equal. I want it to equal the right-hand side, which is cotangent of theta. Moving on to number 5. So again, I want to make the left side equal the right-hand side. Make the left side look like the right-hand side. So I got to try something. This is what I'm going to do. I'm going to rewrite this as 1 over sine, cosine over sine. I'm going to leave cosine alone. At this point, I notice that I can pull out a cosine out of this binomial in the denominator. So this is what I get. 1 over sine theta plus 1, cosine of theta, which is the common factor of this binomial, is outside. Now you should be able to see that I have the same factor in the numerator and the denominator. So at this point, they cancel out. And I'm left with 1 over cosine, which I know is equal to secant of theta, which is equal to my right-hand side. Moving on to number 6. Okay, again, they're a little bit challenging, but with practice and as you're doing the homework, you can ask questions. It shouldn't be too bad, but it's a skill that you develop by practicing. So 6, so this is what I have. What I'm going to do, of course, I'm going to work on the left-hand side. And I basically give each of these numerators its own denominator. So, excuse me. So everybody gets sine theta here in the denominator, cosine of theta here. And what I did here, I distribute this negative, and that's why you see negative here, and this is why you see positive here. Now at this point, this is a 1, This is a 1. These two 1s go away. And at this point, I have two fractions that don't have the same denominator. So what I'm going to do is I'm going to make them have the same denominator. So multiply this one by cosine top and bottom, sine top and bottom. And this is what I get. At this point, cosine squared theta plus sine squared theta, every single one of you should know that this is equal to 1. Leave the denominator alone, and at this point, you should be able to see that it's equal to the right-hand side. Moving on to number 7. Again, verify. So I'm going to work with the left-hand side. I'm going to use a cofunction identity, and I'm going to use the fact that tangent is odd. Cannot forget about what we saw in the previous chapter. So this is why we have negative tangent of theta, cofunction identity. This is equal to secant of theta. At this point, I just rewrite everything to with this one reciprocal identity, and tangent, these are the quotient identities. And at this point, do a little bit of pre-algebra. I multiply top and bottom by the reciprocal of the denominator. And this is what I get. I simplify this. This goes away, and I'm left with negative cosecant theta, which is what I want it to equal. Number 8. This one's a little bit long, but it is what it is. So let's go ahead and do it. So what I'm going to do, I'm just going to focus on this fraction here. So what I did is I multiplied top and bottom by y minus secant theta. I multiplied basically by 1, which is 1 minus secant theta over 1 minus secant theta. Why did I do that? Because I gotta try something. And this is one of those skills that you're gonna have to develop. And why do you do this? This is the idea of a conjugate. You probably use the idea of a conjugate in Algebra 2, and you're going to continue to use this in this course, but now with trigonometric functions. Okay, now let me continue. So what I'm going to do is I'm going to multiply this FOIL, and I get this. At this point, I'm just going to leave this alone, bring in the right-hand side just the way it is. This part of the left side of the equation. This stays the same, stays the same. I haven't touched this. Eventually I'll do something with that. Now at this point I'm going to be looking at the Pythagorean identities. 1 minus secant squared theta is equal to negative tangent squared theta. Play with the Pythagorean identities and you should be able to see that's true. If you need clarification, talk to me in class and I'll be more than happy to explain why. Shouldn't be too complicated though. So now at this point I notice that I have tangent squared theta and then tangent of theta in the numerator. So of course I'm going to get rid of one of the factors here. In addition to that, this negative, I am going to divide it into this binomial, and that's why I have secant of theta positive, and now the positive 1 becomes negative 1. At this point I notice that I have the same denominator. So then this is what happens. This actually cleans up. I should have shown you this part of it. But anyway, you have secant of theta, tangent of theta, minus 1 of tangent over tangent of theta, plus 1 over tangent of theta, plus secant of theta over tangent of theta. And then these two cancel out, and you're left with 2 secant of theta over tangent of theta. At this point, I leave this alone. I use the reciprocal of tangent of theta, which is cotangent of theta. It's in the denominator, so now it becomes times cotangent of theta. At this point, I change this to a reciprocal identity. Cotangent is cosine over sine. Goes away. At this point, I clean it up, and I have 2 cosecant of theta equals 2 cosecant of theta, which is what I want it to equal, and I'm done.